Next is matrix match type question. Question number 56 says that if n is a natural number greater than 3 and CR denotes NCR, then let's solve the following options. So firstly, option number A, it says J into Ci and summation 0 is less than equal to I is less than equal to J is less than equal to N. So if we put I equal to 0, then we have NC0 into. So J can be 0, 1, 2, 3, anything up to N. So this is 0 plus 1 plus 2 up to N. Similarly, let's put I equal to 1. So we can have J equal to 1, 2, 3 up to N. That is 1 plus 2 plus 3 up to N. Plus, when we put I equal to 2, then we will have 2 plus 3 and so on up to N and so on up till. When we put I equal to N, so we have NCN into only N will be there, right? Now, let's find its summation. See, this can be written equal to summation R equal to 0 to N. Let's take NCR into N into N plus 1 by 2 minus R into R minus 1 by 2. Why we have written this? See, let's talk about, let us say, this term. So here we have NCR into. Let's take firstly summation from 1 to N. So here we have added one extra. That is summation from 0 to 1. That is summation from 0 to R minus 1. So its sum is R into R minus 1 by 2. So that is why we have written it like this. So this can further be written equal to N into N plus 1 by 2 can be taken out. So from the first summation, we have NC0 plus NC1 plus NC2 and so on up to NCN. Its value is 2 raised to the power n minus. Next we have summation for R equal to 0 to N. NCR can be written as N factorial divided by N minus R factorial, and here we have R factorial in the denominator, which can be written as R into R minus 1 into R minus 2 factorial. First two terms have been cancelled with the numerator. So here we have 2, right? So this is equal to N into N plus 1 by 2 into 2 raised to the power N minus. So this can now be written as N into N minus 1 into summation of R equal to 0 to N minus 2 C R minus 2. This can be written as this one, right? Now summation of R equal to 0 to N, this will not be the case. R will go from 2 to N. So this is equal to N into N plus 1 into 2 raised to the power N minus 1 minus N into N minus 1 into 2 raised to the power N minus 2. Now this is equal to, see here we have upon 2 also. So this is N minus 3. So let us take N into 2 raised to the power N minus 3 common. So we are left with 4N plus 4 minus N plus 1. So this is equal to N into 2 raised to the power N minus 3 into 3N plus 5. Now here we see that N into 3N plus 5. This is always a multiple of 2. Why? Let us say we take N equal to an odd number. If N is an odd number, then this is odd, but this will be even. And if we take N equal to even, then N will be even. So this is definitely a multiple of 2. So we can say this whole value is multiple of 2 raised to the power N minus 2. Right? Now, from the given options we see option number P is correct, option number Q is correct, and it will also be a multiple of 2 raised to the power N minus 3. So R is also correct. So answer is P, Q and R. Now, let's talk about option number B. It says if N is equal to 2 square minus 2 into NC2 plus 3 square minus 3 into NC3 and so on. See, N is definitely equal to summation R square minus R into NCR, where R is going from 2 to N. So this is equal to summation R into R minus 1 into NCR can be written as n factorial, that is n into n minus 1 into n minus 2 factorial divided by n minus r factorial into r minus 1 into r minus 2 factorial. So these two will get cancelled. So this is equal to n into n minus 1 taken common, summation of r going from 2 to n minus 2 c r minus 2, right? So now this summation is nothing but 2 raised to the power n minus 2. So this is equal to n into n minus 1 into 2 raised to the power n minus 2. Now here also we can see n into n minus 1, that is again a multiple of 2. So in whole it is a multiple of 2 raised to the power n minus 1, right? So it is divisible by n, that is true. Q, R, S, all are correct, right? Now let's talk about option number C. It says summation 0 less than equal to I less than j less than equal to n, Ci plus Cj. When we put I equal to 0, then we have C0 plus j can be 1, 2, 3 up to n, that is, let us say C1, then C0 plus C2, then C0 plus C3, and so on up to C0 plus Cn. Similarly, when we put I equal to 1, then j can be 2, 3, 4 up to n, that is C2, C1 plus C3, C1 plus C4, and so on up to C1 plus Cn. Similarly, when I put I equal to 2, so we have C2 plus C3, C2 plus C4, and so on up to C2 plus Cn, right? Similarly, it will go on until we put I equal to n minus 1. Then it will be j can only take the value n, so this is Cn, right? Like this we will get a series. Now this is equal to, see, we can see how many times C0 is repeating. C0 is repeating only in the first line, that is n times. So this is n into C0 plus. Let's look out for C1 now. How many times C1 is repeating? Here C1 is there. Here in the second line C1 is there. Now in second line C1 is repeating n minus 1 time. In first line 1 time. So this is also n into C1. So in the similar pattern we will see C2 is also repeating n times. So we can write it as n into C0 plus C1 plus C2 and so on. Similarly, we can look for Cn is also repeating n times. So this is equal to n into 2 raised to the power n, right? So from the given options, let's see P, Q, R, S will be the correct answer. Now let's talk about option number D. It says summation I less than j greater than equal to 0 less than n, Ci plus 6 times j. So this is equal to, when I put I equal to 0, then we have C0 plus 6 into 1 plus C0 plus 6 into 2 plus C0 plus 6 into 3 and so on up to C0 plus 6 into n. Similarly, when we put I equal to 1, we have C0 plus 6 into 2 plus C1 plus 6 into 3 and so on up till C1 plus 6 into n. And so on it will go up to, when we put I equal to n minus 1, then we will have plus 6 times n, right? So this is equal to, now we can see in first line C0 is repeating n times, that is n C0. In second line C1 is repeating n minus 1 times, that is n minus 1 into C1, and so on up to Cn minus 1, it is repeating just 1 time, plus 6 into, from first line we have 1 plus 2 plus 3 up to n plus. From second line we have 2 plus 3 up to n. From third line similarly we have 3 plus 4 up to n, and so on up till in last line we have only n. So this is equal to, now to find the value of the first bracket, if we differentiate 1 plus x raised to the power n and put x equal to 1, so we will get n into 2 raised to the power n minus 1. That will be the required value of the first bracket, right? So this is n into 2 raised to the power n minus 1 plus 6 times. See, this series, this can be written as n into n plus 1 by 2. This is written n times minus summation r going from 1 to n minus 1, r into r plus 1 by 2. See, let's talk about this one. So here we have added 1 plus 2. Then we will get the series from 1 to n, that is n into n plus 1 by 2. And from here we will subtract the series from 0 to 2. So summation of that will be r into r plus 1 by 2. So this is equal to n into 2 raised to the power n minus 1 plus 6 times n square into n plus 1 by 2 minus summation of 1 by 2 into r square, that is divided by 6 plus similarly summation of r, that will be, right? So when we will solve it, we will get it equal to n into 2 raised to the power n minus 1 plus n into n plus 1 into 2n plus 1. This is the required value, and this can be seen that this is divisible by n. So only answer will be option number P. Next is matrix match question 57. Option number A says that a complex number z satisfying z minus 2 iota less than equal to 3, then mod iota z plus 3 can take values. See, mod iota z plus 3, it can also be written as iota, let's divide by iota inside the modulus. So it is z minus 3 iota. Now, if we talk about modulus of z minus 2 iota, it is representing a region inside the circle whose center is 0, 2 and radii is 3. So this point is 0, minus 1 and this point is 0, 5. So z is representing all the points inside and lying on this circle. Now we have to talk about z minus 3 iota modulus, that is, this is 0, 3. So z minus 3 iota modulus, it can take the value, this one, that is 2, and if we join this one, then it is 3 plus 1, that is 4. So it can take values from 2 to 4. So from the given options we can see P, Q, R are the correct answer. I hope this is clear. Now option number B, it says if the greatest coefficient in the expansion of 1 plus x raised to the power n is 1 by 24 n, n minus 1, n minus 2, n minus 3, then n can be. See this value that is written over here, this is NC4, right? Now if NC4 is giving the greatest coefficient, generally middle term is giving the greatest coefficient, so we can say value of n can be equal to 7, 8 or 9. So from the given options, T will be the correct answer. Now option number C, it says for a complex number z, the minimum value of mod z minus 3 whole square plus mod z minus 3 iota whole square plus mod z square is greater than. See, minimum value will lie at the centroid of 3, 3 iota and 0. So its centroid is, let us say, z0 equal to 1 plus iota. So minimum value will be obtained at z equal to 1 plus iota. So we have mod of minus 2 plus iota whole square plus mod of 1 minus 2 iota whole square plus mod of 1 plus iota whole square. So this is 5 plus 5 plus 2, that is 12. So this is greater than all the values given. So that is PQRST will be the correct answer. Now option number D. It says if n is given a value from the set 1 to 12 at random, the probability that the value of 1 plus iota raised to the power n is real is. So here either you can put the values of n as 1 to 12 and see which of the value is giving real, or what you can do is 1 plus iota raised to the power n can be written as root 2 raised to the power n into e raised to the power iota pi by 4 n. As this is real, so its imaginary part will be 0, that is sine n pi by 4 is equal to 0. So from here we can see that value of n from the given set can be 4, 8 and 12, which means probability is equal to favorable values are 3 and total values are 12. So probability is 1 by 4. So value of 1 by p is 4. So correct answer is R.